G'day guys, this is a video on inequalities. So an inequality is a statement like an equation, but instead of an equal sign it's got one of the less than, greater than or less than, equal to or less than, greater to or less than, or equal to, and greater than sign. Okay, so the idea with these is that when you solve them you get a range of results, okay, rather than just getting a single answer. So you're not going to get x equals 3, you're going to get x equals greater than 3. Okay, so the good thing about inequalities is you solve them using the same methods as the equation. There is one exception, and I'll show you this specifically when we get to it. But when we're dividing or multiplying by a negative value, the inequality sign is flipped. Okay, so if it's a less than, once you divide everything by a -1, you flip it and it becomes a greater than. Okay, so let's get down and do a couple of these just to show you how we do it. So 3x plus 4 is greater than 13. So a lot of you remember this symbol as this is the greater than symbol. Okay, it doesn't matter. We'll go through that in class. Anyway, so the way we solve this is we take 4 from both sides, which gives us 3x is greater than, now that 13 taken by 4 is 9. Now we divide by 3 here, cancel out the 3's, and we have x is greater than 3. Okay, so it's as simple as that. It's often easy to leave out or change this to an equal sign. It's really important that you don't. Okay, that stays as a greater than all the way through. Now, this one here is a little bit trickier. Okay, so 4 minus x over 3 is less than or equal to 6. Now, a lot of you might be tempted to, when solving this, is go straight to the 3 and times everything by 3, but you don't. Out the front is a plus 4. Okay, so you've got to take away that first. Alright, so we're going to take that away first, because that is actually the last thing that's been done to the x, or the x, the pronumeral. So minus 4 from both sides. Okay, and we're left with this negative belongs at the front. Okay, and 6 minus 4 is 2. Okay, now what we're going to do now is, this is a little bit tricky because we're going to a negative out the front here. Whoops. So at some stage we're going to have to divide by or multiply by a negative depending on which one we use. Okay, when there's a fraction like this, either the top or the bottom is negative. Okay, what I'm going to do here is actually make, and I can do this as long as it's only one on the top of the other. I'm going to put the negative on the bottom here. Okay, I can do that with a fraction. What I'm going to do is I'm going to times both sides by -3. Okay, that gets rid of my negative at the same time. So x cancels out, and we get 2 times -3. Okay, and normally you just put an equals in there if it was an equation, but it's not. It's an inequality. And remember when I said when you times by or multiply a negative number here, whoops, it's not very easy to see, you have to flip the inequality. Okay, so this was less than or equal to, it's now become greater than or equal to. Alright, so we flipped it over. And that's our answer. So x is greater than or equal to -6. Okay, so finally over here, we've got one with a variable on both sides. Again, we solve it just like inverse operations. So I've got to get all the x's on one side. So what I will do, I can move them to left or right. If I move them to the right, I'm going to avoid a negative x term. Okay, so if I take 3x from here, I'm going to be left with 3x's on that side. So it cancels out. We get 2 is greater than or equal to 3x minus 4. Okay, so the next step is to get rid of the constants, the numbers. So plus 4 on both sides. Okay, and what do we get here? 6 is greater than 3x. Okay, the last step, we've got to get rid of the 3. We divide by 3, it's like that. Okay, and that's 2 is greater than x. Now, yeah, one more exception here. So I guess it's not really an exception. It's sort of it's just something you've got to get straight in your head. Now, when we have an equation, so say if it was 2 equals x, that is exactly the same as x equals 2. Okay, that's the same thing. When we have, oops, When we have something like this, however, okay, if I want to put the x on the other side, so this is saying 2 is greater than x, but logically, we'd have to flip the sign as well. So x is less than, less than 2, okay?